Hello team, today's challenge is Array Sum Finder, where we're given an array and a target, and we need to pull out the values, the first values, the values closest to the start that add up to that sum, or if we don't find anything, we return sum not found. Now these values could be anywhere, they aren't going to be consecutive or contiguous, however you want to say that, right? It could be the first and the last, or the two in the middle, or anything like that. So we need to account for how to do that. And today I'm going to use recursion, okay, which you'll see right now. So over here, we're going to set up a variable, okay, and we'll call this subset because that's what we're going for, right? We're going for technically the first subset, but we'll let that ride. And we are going to call this find first subset. Probably a terrible name, but we will do that. We're going to pass in the array and the target, and that is going to be our recursive function. We'll come back to that in a second. The return, okay? If we get a result, we return it. But as you'll see in a second, we could return null. And if we return null, then we should return that string, which was sum not found, okay? So this is it for the main body. Everything else happens in this find first subset function, okay? We go up here, we create it, function, spell it right, and dropping in, okay? With most recursion, again, you really want an exit strategy, right? You don't want this to become a runaway loop. You don't want any loops to be runaway, honestly, but especially with recursion because they will eat your memory, right? Every time you call this function, it's dropping more information into memory. So that feels like a bad plan to me, which means that we should get the exits out of the way first, which is usually how I write this, okay? So if target, okay, we're going to alter target as we recurse through this. In fact, we are going to subtract viable options from it until it hits 0, okay? If that's true and the current dot length, okay, which is a variable that we haven't created, if that is greater than equal to 2, because we need at least 2 values in there, otherwise it doesn't work, okay? Even if you find the exact same value, if we had an array, a target of 6, and that array had a single value of 6 at the very start of the array, well, we don't want it because we want a subset. We want that array. But maybe we do. I mean, they do have somewhere in here, yeah, subset of 2 or more. So for their challenge today, they want 2 or more. But if you were writing this, maybe you just want that one value, right? That's a topic of discussion. Let me know in the comments what you think of that. But right here, if this is true, then we return current. What is current? Well, that goes up into our arguments just like this. Current is going to start as an empty array, which is why we didn't need it down here, but we definitely will when we call this inside of the function, okay? The other thing that we need to know is the array, okay? So as we're working through, we're going to subtract things off of target and pass it back in. We're also going to remove the first element of array each time. So we're reducing the size of our array as we're going through and pulling that first element off, okay? If that is where we want it to be, if that array, if the length of it is equal to 0, it means that we've hit the end of the line. There are no more numbers. We didn't catch on this one, so this must be return null, okay? Some of you might want to, might think to return undefined like this. My fingers didn't even want to type it because technically that's wrong, okay? Undefined is for a variable that has not been assigned yet. Whereas if we're returning, we should always return null, okay? Instead of undefined. So null it is. It won't matter down here because of how this nullish coalescing operator actually works. So yay us, right? Now that we've covered those, so we've covered the happy path where we've hit 0 and we have enough elements inside of our current array we just return it. We feed it all the way back up the chain until we're back to our first call, at which point it's here, and send it out the door, okay? If we've run out of elements inside of our array, we return null, send it all the way back up the chain, and return some not found. So all that's really left is to do the work. And for the work, we are going to set up a variable. It's going to be called found. And on that variable, we're going to find first subset, just like this, and toss it some items, right? What are we going to toss it? Well, we're going to say array slice 1, okay? So we're getting everything from the first item to the end. Brilliant. And then our target, okay? Our target is going to be target minus the array 0, okay? So we're subtracting from there until we hit that 0, or if it's null, okay? Which is also okay. And then from there, the last thing that we're going to do is we are going to build out our current array. So we're going to take whatever the current is, whatever we've passed in, and feed it array 0, okay? Now, if we've found something, there's a chance that we might not find something. So we're going to branch in a second. But if we found something, so right here, we're going to return that found thing, okay? Which in this case will either be null or current if we found something, okay? If we didn't find anything, then we do this exact same thing over again. So we go here, copy it down, jumping around, pasting it in, but instead of making a variable, we're gonna just return, okay? We're gonna return, what are we returning? Well, it's gonna be slice, it's going to be the target because that shouldn't change, and it's going to be the current because that shouldn't change, okay? And at this point, it works. It works brilliantly. The way that this does work, in case you're wondering, is right here we have that branching logic. It's separated by this condition, okay? We try to use array item 0, whatever that is, okay? Whatever current number that is, we feed it into here and see if it works. If it does work, great, we return, right? If it doesn't work, we get null. At which point we say, you know what? I didn't find anything, so let's try it again this way. And this time we just ignore that element and return the next set of the array, right? From 1 to the end, leaving the target and the current as is. So this is kind of a weird if-else statement, right? The way that it's been structured, but it does get the job done, okay? So that's it for today. Again, not every solution, but hopefully one good solution. We did do this recursion a little bit different than I usually do, right? Usually we do some sort of concatenating, but I needed that current to be in there so that I could get the length. So passing the current in so that we can calculate that, and then based on that, we either act on it or we return current or null. We go down and then we go back up and feed that out to subset or return some not found, okay? Again, that's it. So if you found another way, let me know in the comments. If you like this, if you hate this, if you have questions about it, let me know all that stuff in the comments as well. Otherwise, today this has been Array Sum Finder, and I will see you tomorrow.